Hi everybody, again welcome to Maths YouTube channel Maths Insights. I am your maths teacher Shiva. Today's topic is when we say two lines are parallel and perpendicular. Before going into discuss parallelism and perpendicularity of two lines, we have to know what is meant by inclination and slope. Inclination is nothing but angle made by any line with a positive x-axis in anti-clockwise direction. If you see, this is x-axis and this is y-axis, and I am taking a line called L. This line L is making an angle theta with a positive x-axis in anti-clockwise direction, then that is called inclination. If you know the inclination, it is very easy to find the slope. That is, generally slope is denoted by using the letter m. M is equals to tan theta. If the theta is measured by using trigonometric ratio tan, we will get the slope of that line. Now here, what is the condition? If you have to say two lines are parallel and two lines are perpendicular, what is the condition for parallelism of two lines? I am taking two lines called L1 and L2. Let their inclinations be alpha and beta. Let m1 is the slope of the first line and m2 is the slope of the second line. Now, therefore, m1 and m2 are the slopes of the lines. Two lines alpha and beta are the inclinations made by these two lines. If the lines are parallel, see, they have given that they are parallel lines, then automatically inclinations of those lines are automatically equal. That implies to alpha is equals to beta. When alpha is equals to beta, we may apply tan on both sides. Tan alpha is equals to tan beta. That means tan alpha you know very well. Tan alpha is the slope of the line L1 and tan beta is the slope of the line L2. Means instead of tan alpha you may write m1. You just before defined that slope of any line is tan alpha or tan beta depending on the inclinations made by those angles. M1 is equals to, that means m1 is tan alpha and in place of tan beta I will write m2. So if lines are parallel, their slopes will become equal, and conversely if the slopes are equal, then their lines are parallel. We will prove that also. Given that, what they have given that slope of the first line is equals to slope of the second line. Whenever slopes are equal, their inclinations will also become equal. That means in the place of m1 we will write tan alpha. In the place of m2 we will write tan beta. Why? Because m1 is the slope of the first line, m2 is the slope of the second line. On both sides, if you remove tan, we will get tan alpha is equals to beta. Otherwise, property of tangent function, when the angle is between 0 and 180 degrees, automatically alpha becomes equals to beta. That means these inclinations are equal. Means whenever inclinations are equal, then the lines are parallel. Therefore, L1 and L2 are parallel. This is very simple. So in two conditions, when inclinations are equal, when the lines are parallel, we are showing that their slopes are equal. When slopes are equal, then the lines are parallel. This is the condition for parallelism of two lines. Again, if two lines are parallel, then their slopes are equal. Conversely, if the slopes are equal, then the lines are parallel. Next is condition for perpendicularity of two lines. I am taking two lines, let L1 and L2. If these lines are perpendicular to each other, what happens? what is the relation between slopes of these two lines. Here also alpha is the inclination made by the first line L1 and beta is the inclination made by the second line with positive x-axis in anti-clockwise direction. First condition, suppose if they are perpendicular, if the lines are perpendicular, what happens? What is the relation between the slopes of those lines? Clearly they are saying that these two lines are perpendicular, then angle here will become 90 degrees. Whenever that is 90, this angle will also become 90. Why? Because these two are vertically opposite angles. If you see like that, then this is a triangle. Now this angle is the external angle. We know that from the properties of a triangle, an external angle is equal to the sum of opposite interior angles. For this triangle, this is external angle and this 90 and alpha are internal opposite angles. Therefore, from the diagram, beta is equals to alpha plus 90. Since they are clearly saying that the two lines are perpendicular, automatically this beta minus alpha is equals to 90 degrees. Means difference between these two are 90 degrees. Then I am applying tan here itself. Tan beta is equals to tan of alpha plus 90. Applying tan on both sides, we can write it as tan 90 plus alpha also. Tan 90 plus alpha becomes minus cot alpha. Minus cot alpha. Cot is the trigonometric ratio which is reciprocal of tan. Therefore, we can write it as minus 1 by tan alpha. On cross multiplication, tan beta into tan alpha is equals to minus 1. Therefore, tan alpha into tan beta is equals to minus 1. We know that tan alpha is the slope of the first line. As defined earlier, tan alpha is equals to m1, slope of the first line. Tan beta is equals to slope of the second line. Tan alpha into tan beta is equals to minus 1 means m1 into m2 is equals to minus 1. This is the condition when two lines are perpendicular. Means the product of their slopes is equals to minus 1. Conversely, if the product of their slopes is minus 1, then they are perpendicular. So if m1 into m2 is equals to minus 1, where m1 is the slope of the first line, m2 is the slope of the second line, we can write it as m1 is slope, means you can write it as tan alpha, and m2 means tan beta is equals to minus 1. We will write it as tan alpha is equals to minus 1 by tan beta. Tan is the reciprocal of cot, therefore you can write it as minus cot beta. This cot beta can be written as, this cot beta can be written as tan 90 plus beta. Why? Because 90 plus theta is in the second quadrant. In the second quadrant, cot as well as tan are negative, that means they will get opposite sign. Therefore, tan alpha will become equals to tan 90 plus beta. That means this here tan alpha is equals to tan 90 plus beta. If you remove tan on both sides, it will become alpha is equals to 90 plus beta. Means alpha minus beta is equals to 90 degrees. What it means? The difference between alpha and beta is 90 degrees. Then the lines are said to be perpendicular. This is the condition for perpendicularity and parallelism of two lines. Again I am saying, if two lines are parallel, then their slopes are equal. Conversely, if slopes are equal, then the lines are parallel. Coming to the second condition, if two lines are said to be perpendicular, if the product of their slopes is equals to -1. Conversely, if the product of slopes of any two lines is equals to -1, then the lines are said to be perpendicular. This is today's video. I hope this video is helpful to you. We will meet again in the next video. If you like this video, please subscribe, share and like it. Thank you very much.